Welcome AP Electricity and Magnetism students. I decided that instead of posting a PDF document of the solution to last night's homework problem, I would create a video of the solution. And the reason why is that this way it's easier for me to talk about my thoughts in answering a question like the one from last night. Also to talk a little bit about the types of strategies you want to use when answering such a question. These things would be more difficult to achieve with a static PDF document. So that's why I'm creating yet another video here. So again, the question is from AP Classroom, FRQ : short, a design your own experiment type of question. So you've seen it, you've read it, and you've solved it, but I'm going to read it anyway. So they provided you this little picture of a circuit here, and they said a group of students are to experimentally determine the internal resistance lower R of a battery using the circuit created as shown. The battery is assumed to have an internal resistance of little r and a constant emp, the symbol there. And I highlighted this. The students are expected to find the internal resistance by plotting their data in a graph. Why did I highlight that? Well, because a graph is implying that you're going to have multiple trials, that you're going to be changing one variable and seeing its effect on another, plotting it in a graph, and then seeing some kind of pattern, maybe a curve, maybe a straight line. Well, that depends on the experiment, but it does imply multiple trials with a graph, obviously. The students have access to equipment including but not limited to a variety of resistors, multimeters, and other equipment commonly found in a high school physics laboratory. Now the physics, so you got to start thinking right away. What are they trying to get me to do here? The physics that they're trying to get you to utilize is Ohm's law. Okay, so one possibility is if you put current on the y-axis and resistance on the x-axis, we would get a 1 over x graph like this. I equals V over R in Ohm's law. So then if we did such an experiment where we were varying this resistor and measuring the current, we'd see this, and we'd have to do some kind of technique to create a straight line. Remember, that was either squaring a variable on one of the axes, doing a reciprocal, taking the sign of one of the variables. It depends on the experiment, but we're going to have to do a little bit of effort here to get this into a straight line. The simpler possibility using Ohm's law is to think of it as V equals IR. And if you plot V equals IR, I on the bottom axis, V over here, that actually is a straight line like this, with the slope being equivalent to the resistance. Okay, so that's the way I'm going to go. I think from the comments and questions I saw in Google Classroom, I think a lot of people went this way, the more complicated way. I'm going to show you both ways to go, both solutions, both answers, because I want also to emphasize that in these design your own experiment questions, they are open-ended. And that means that you can come up with multiple correct answers. Okay, so that's what I also want to show. All right, so more about how am I going to do this. What I could do is I can vary the resistance, which will vary the current. If I put more resistance, I'll get less current. Less resistance, I'll get more current. And I'm going to measure the current by putting an ammeter somewhere in the circuit, like maybe here. And then I'm going to measure the terminal voltage of the battery by putting voltmeter probes here and here. And what I'll see is that as the current increases, the voltage, the terminal voltage of the battery decreases because of this internal resistance. So what I will actually see is the terminal voltage this is delta V of the battery, will actually drop like this as a function of current. And I don't know if you remember that thing here, but that's basically what we're going to do. Terminal voltage of the battery. So let me show you first my solution, okay? And what I want to do before I go into the details is I want to show you or point out that some of the answer I typed and some I got out a paper and pencil and wrote the solution out. Me personally, I type faster than I write. So when I'm answering words and sentences, I stick to typing and I load those typed answers, those text files right into the test, okay? But when it comes to doing something with equations, I get out a piece of paper, pencil. I would recommend that when you're taking the AP test on Monday, you have a stack of clean paper next to you. If you type something in, fine, but if you have to calculate something, grab off a clean sheet, write it out, snap a picture, load it, right? Like we practice on the practice test. So switch between whatever's more convenient to that particular question, switch between techniques. All right, so this is again that thinking that I said. So now let's look at the details. I'm skipping ahead to part D because this is what you have to do in your mind. You have to come up and understand the calculation before you can come up with a procedure. So if I measure the terminal voltage of the battery, it's going to drop the more current there is. Remember I said when we were studying this, you could use like a Kirchhoff's loop rule analysis. Imagine yourself being a little tiny ant with a tiny voltmeter walking through the circuit. If you start down here and you walk through the battery, you're going to see a voltage drop, I guess if we're going in the direction of the current, through the resistor of V equals IR. So going through, I actually have this backwards, minus IR, I go through the resistor, then the ant walks from the negative parts of the chemical reaction in the battery to the positive part. So it goes up plus EMF, okay? So from here to here, the voltage is minus IR plus EMF right here. This is the equation of a straight line. If I put this first, I would see y equals mx plus b, this being the slope. So that's my thinking. I'm going to do that and I'll get the slope that way. So I have to kind of have that in my mind before I start coming up with a procedure. Again, this is part D. I'll come back to it in a second. So knowing that that's the approach I'm going to be measuring currents and voltages and plotting these in a graph and getting a straight line. Let's proceed then to describing that procedure. So part A, clearly identify each quantity to be measured, the symbol used, quantity to be measured, symbol used, and the equipment you will use to measure that quantity. 3 things for everything you're going to measure. Obviously, if you're in a lab in school, you could tell your lab partner, hey, go over and measure the resistance of this resistor. You don't have to say, oh, go use the ohm meter. Obviously, they're not going to use a stopwatch. They're going to know what to use, right? So that's common sense when you're talking, but you can't answer the question this way. They want you to say, don't measure the voltage, use a voltmeter. What else are you going to use to measure voltage? Well, voltmeter, but you have to say, use a voltmeter to measure the terminal voltage. So there's the second thing. And then you need a symbol, dV. Now, obviously, we use delta V. But again, when you're typing, before the question, there was a paragraph here that said this year on the AP, since you're doing it online, you're welcome to use other symbols that are more convenient because getting delta into word processors is not always easy. Okay, so I use dV to use, so I state that right in the beginning. And then I'm going to use an ammeter to measure current in the circuit I, right? So I have the ammeter, current I. Those are the 2 things I measure, okay? So here's my procedure. And again, you want to be brief but complete. So in the circuit shown above, attach the probe wires of the voltmeter to either side of the battery. Then open the circuit and complete again with the ammeter so that it will measure the current I, right? So we put the ammeter in the circuit. Second step, measure the current I and the terminal voltage of the battery, delta V. Now, I have to use these symbols because, see, this is saying describe a procedure used to determine the internal resistance, provide enough details so that another student can replicate the experiment, including any steps necessary to reduce experimental uncertainty. Here, as needed, use the symbols defined in part B. So I have to actually say, all right, measure the current I, delta V, right? Measure current I, delta V, right? So the next step, remove the resistor in the circuit and replace it with a larger resistance. Use the ammeter to measure the current I and the voltmeter to measure the voltage delta V. Now, you may not need to say using the ammeter here, because you kind of already set it up. Oh, we did say it there, but the voltage, right? But stick it in there anyways. Be as complete as possible. I don't think it takes too much time. Again, 3 things for every measurement: what you're using, what you're measuring, and what the symbol is. Okay, repeat until you have 8 distinct pairs of current and potential difference, changing the resistance each time. So there's my procedure. I believe it's complete enough for another student to be able to replicate that. Okay? Part C. Which quantities, raw data or calculated from the graph, would be graphed on the x and y axes to produce a graph that could be used to determine the internal resistance of the battery? I would plot current on the horizontal axis and potential difference. Well, I probably should have said terminal voltage, but yeah, I guess it's already kind of saying the same on the vertical axis. So again, as I said, right here, terminal voltage and current on the horizontal axis. All right, now part D. Describe which information from the graph described in part C would be used and how it would be used to determine the internal resistance of the battery. So I kind of went over this already. The first thing I want to state is I would draw a best fit line and then calculate the slope. Okay, so you want to say that it's the best fit line. Again, they said they wanted to minimize experimental uncertainty. And so that's what the best fit line does. It's like an average, but a graphical average. Okay. Now, what am I going to do with that slope? I have to, I did say, oh, calculate the slope. Well, that's not telling me what I'm looking for. They're saying, you know, somewhere here, we want to determine the internal resistance R. So how do I use the slope? So I use that Kirchhoff's loop rule kind of analysis from here to here. I already explained this. So now I can see from y equals mx plus b that basically my y-intercept is the nth of the battery. That doesn't help me. I don't need that. But this part right here, this is the internal resistance. The slope is negative internal resistance. So therefore, the internal resistance is the negative slope. There. That's the answer there. Okay, part E. After completing their calculations, the students begin to consider the factors that might have produced uncertainties in their results. The students realized that they did not take into account the resistance of the wires used to connect the circuit. Briefly describe how this would affect their calculated value of the internal resistance of the battery. Explain your reasoning. So, my answer, that says C, I don't know why, should say E, that doesn't matter, okay. It would have no effect. Since the current and the potential difference were both measured, the effects of wire resistance were already included. So I measured the current, I measured the voltage, therefore the resistance of the wires had already established a particular current, which I measured. So I've already included the resistance of the wires by using the ammeter to measure it. It already factored that in. So no effect on my answer. Okay, interesting there. All right, as I said, I want to show you a second solution, which many of you, it's a solution you probably did because it was similar to what we did when we did this as an experiment. Okay, so here's solution 2. So again, we got to know where we're going before we start writing the procedure. So maybe you do this on a scratch paper, I don't know, but you got to figure this out before here. So the first thing, I use Ohm's law. I equals voltage over resistance. And the voltage in the circuit is the nth, and the resistance is these two in series. This creates a curve, and I want a linear graph. So what I'm going to do is take the reciprocal of both sides. 1 over I on this side, and then the R's on top, and then the nth on the bottom. I could now split this up into 2 fractions. I could not have done that here. I couldn't have said nth over R plus nth over R here. That would be not correct algebraically. So now I split this up like this, and it's evident right here, but I'm going to rewrite it just like this. So 1 over I, there's my y-axis. This is on the x-axis. The slope is now 1 over nth. That comes from this term. So y equals mx plus B. So the internal resistance will be determined by the y-intercept. So there's the thinking. Now that I know where I'm going to here, I can start coming up with a procedure where I'm going to be measuring the current R, measuring the resistance R, measuring the current, creating a data table, and making a third column of 1 over I to get a straight line like this. Okay, so now, knowing that, let's now write out the procedure. So A, again, I don't need to read this. It's, what we're going to be measuring. So now I'm going to use an ohm meter to measure the resistance R of each of 8 different resistors. So there it is, the ohm meter. Again, right, 3 things. What are you using? What are you measuring? What is its symbol? Okay. Next thing, I'm going to be using an ammeter to measure current I. Okay, 3 things again. All right, B is the procedure again. So I measure all the resistances R of all the 8 resistors, including the original one in the circuit. Right, so I measure all these R's, and I have 8 different R's. Open the circuit shown and complete it again with the ammeter so that it will measure I. Right, so I want to have the current measured, and I'm going to be and I already measured the R's. Measure the current I, okay, and then repeat the last step with each resistor alone in the circuit shown, measuring the current I each time, okay. So as I already worked out over here, so part C, what am I going to graph to determine the internal resistance? So as I said over here, 1 over I and R. So I would plot resistance on the horizontal axis, and then the reciprocal of 1 of I, in other words, 1 over I on the vertical axis. And that would give me, 1 over I here, and then something like this, right, with a y-intercept there, and then a straight positive slope of 1 over m. Oh, and R down here, right? So that, again, I didn't have to draw this out, but that's where I'm going because I already kind of figured this out. All right, so part D, describe which information from the graph you would use and how it would determine the internal resistance. So, again, you have to say, you got points right now. You don't have a line. We've got a bunch of points, right? So I would draw a best fit line and then calculate its slope. I would also read the y-intercept. So I get to calculate the slope and read the y-intercept off the graph, okay? And then I already went through this, how I get to here. And then now, notice, in order to calculate the internal resistance, I need the EMF. I never measured EMF. So I have to first determine it from the graph. So first thing I have to do is calculate EMF from the slope. Slope is 1 over EMF, so EMF is 1 over the slope. So now I have this, and I could take the intercept, plug it in. So I use that in intercept is internal resistance over EMF. In other words, internal resistance is EMF times the intercept. So I plug that in there, take the intercept off a graph, and I have achieved the purpose of the experiment. I've determined the internal resistance. I've described, right? I'm not calculating anything, I'm describing. And again, the note I typed here because it was quicker, and then I went to pencil and paper here because it was more convenient. All right, now part E changes with this procedure. After completing their calculations, the students begin to consider factors that might have produced uncertainties in their results. The students realized that they did not take into account the resistance of the wires needed to connect the circuit. Briefly describe how this would affect their calculated value of the internal resistance of the battery. Explain your reasoning. In the previous procedure, it would not have an effect. This time it does. So the answer to E has changed. So here's the circuit. Okay, maybe I'll do it like this. Okay, so now these wires, because I measured current and resistance, the Ohm's law analysis was not correct. So here's the explanation. The calculated value would be larger than actual. So don't say, for example, and I mentioned this in the review video about these questions, don't say the internal resistance would be larger, because that doesn't tell me which internal resistance, the true internal resistance or the one I calculated. So you want to just not say the value would be larger. Which one, the calculated or the actual? I said the calculated value would be larger than actual. State that right up from the front. Why? The wires are in series with all the other resistors, so my Ohm's law calculation is I equals M over total resistance. R, which is this, little r, which is the internal resistor, plus R, and I wrote a little subscript wires. Okay, again, it's not convenient because I'm typing, but the AP is going to be forgiving. I hope. I think they will be, and they said they would. So this is the total resistance of the circuit. So the resistance from the intercept is therefore, R from intercept is going to be these two together. Maybe I'll highlight it, right? So these two together are creating that Y-intercept. So R from intercept is R plus R wires. So as can be seen from the last equation, R from the intercept is greater than the true internal resistance, R of the battery. So there's the explanation for that. Okay, so there are two different solutions to the same question. Hopefully you can see all the things that are necessary, right? So how you read the question, and then you kind of have to determine where you're going first before you make a procedure. Whether you're going to, what you're measuring, delta V versus I, or in this one, R versus I. So you got to know that, right? So you got to do a little quick thinking, a little scratch work first to know where you're going. Once you do that, then you list out the equipment. Remember, everything you're measuring, you need three things. What you're using to measure, what you're actually measuring, and then a symbol. Okay, so there for everything. There, right? So tedious, but make sure you do that. And then when you do your procedure, make sure you put your symbols. Sometimes you could also state what you're using to measure. Be as complete as you can. And then state what, how to make the straight line, and then a little bit about how you analyze that straight line. And then, of course, sources of error. So that's the basic gist, the basic process, again, of how to design your own experiment with graphical analysis. Okay, so that's it. That's probably the last video, well, certainly before the AP. So hopefully you're ready for that second question of designing your own experiment at this point. I want to wish everyone luck, and I want to thank everyone for their hard work. I hope everyone gets 5s. I'll be happy. You'll be happy. Hopefully you get some college credit out of it. Thank you for sticking with it, and I'll see you in maybe some more videos after the AP test. Again, good luck. Do well.